Okay, today we have a Dr. Kristina Lerman from USC. She will talk about collective emotions and polarization on social media, which is really important and important topic these days. I will briefly talk about the speaker's bio. Kristina Lerman is a principal scientist at the University of Southern California Information Sciences Institute, and she holds a joint appointment as a research professor in the USC Computer Science Department. And she was trained as a physicist, and now she applies networks analysis and machine learning to problems in computational social sciences. She is also a fellow of the AAAI, which is a great honor. And then her works on modeling and understanding cognitive biases in social networks has been covered by various important journals, and also including MIT Tech Review. So Dr. Lerman, thank you for joining us, and thank you for speaking to us. And now the floor is yours.
Thank you very much, Jean. And I'm really excited to be here to share some of the latest, my recent work. And actually, this is such an exciting time. I tell actually every 10 years, I tell my students and other people saying this is most exciting time to be in this area. But truly now is the most exciting time because not only do we have lots of data available about human behavior, but now all this very sophisticated advanced tools from large language models are coming online to help us understand human behavior. So we can actually synthesize now both emotion, psychology, social psychology work, network science work, and bring it together on real data to understand human behavior at scale. So this is really exciting, and I hope to communicate some of this excitement to you. All right, so I'm actually trained as a physicist, now working in computer science, but now kind of becoming an amateur psychologist. Why? Well, because emotions, I'm really fascinated with emotions. I became fascinated with emotions about 2 years ago during COVID, when I realized, how important that the emotional regulation is for our mental health. So what are emotions? Emotions are concepts that are useful to interpreting bodily states associated with physiological responses to certain experiences and thoughts. So emotions have evolved over the millennia to help individuals achieve their goals. For example, we feel anger when our desires and preferences are thwarted by somebody. And this emotional anger helps the body to marshal the necessary resources, which is thoughts, plans, behaviors, to help achieve its goals. And another thing that's really fundamental about emotions, although I do realize in psychology there's lots of debate and controversy about it, but there's some universality. All human beings have to experience emotions. And I'm not going to touch, there is apparently a culture war in psychology, whether or not emotions and how they're being expressed are universals. But I think everybody agrees that people do experience kind of a range of emotions, whether they're discrete or continuous, maybe in question, but they're going to be shared across all cultures in the world. At least that's my starting point for this. What I'm interested is also how the role of collective emotions in human life. Now that actually we have connected to each other on a global scale through social media technologies, social networking technologies, we can experience each other's emotions, be aware of each other's emotions. And this is important because now how these emotions will affect all facets of human life. For example, our identity formations, how our attitudes and beliefs form. So emotions help strengthen group bonds and reinforce common beliefs. Emotions, as we are seeing right now when the global conflicts arise, emotions help promote in-group solidarity. They mobilize groups towards common goals, like we see often in social movements. Emotions also play an important role in conflict and polarization, and I'll spend most of my talk covering these topics. For example, they can activate people, they can create social divisions, they can, help, guide us to demonize the outgroup members, people who are different from us. And also, emotions are also important for psychological well-being. For example, there's lots of discussion right now about the role of social media in mental health, and it's mediated through emotions to the large extent. And especially I'm personally very interested in this topic to understand the mechanisms by which social media might affect mental health. And certainly there's a lot of research right now that's showing that social media has eroded the mental health, especially in young people. And I'm interested in studying the mechanism through which it's going on. So what I'll spend most of my talk on is the concept of affective polarization. So actually, I asked ChatGPT to come up with an illustration of affective polarization that outside of the political context. And it was like the brilliant insight that ChatGPT DALL-E had to create this image of this, this is what the picture I'm showing to illustrate the concept. So suppose you have two teams arbitrarily divided based on the location of the team, and you have fans of the sports teams, and each side likes its own members but doesn't like the opposite sides at all. So affective polarization is this concept from political science. It was introduced by Shanto Iyengar in 2015, where it says you have two groups, for example, Republicans or Democrats, or Raiders versus whatever other sports team, pick your analogy. So these two groups, not only do they disagree on issues, for example, they not only do they disagree which team is better, but they also actively dislike and distrust each other. And moreover, they see the other group as a threat to their own group. So this concept can be summarized as in-group favoritism and out-group animosity. And again, it's called affective polarization. And our feelings, our emotions within this concept of affective polarization help us discover who our allies or friends are and who our foes are. Our emotional responses and their emotional responses to different situations. So this is important in the political context, especially because we have this political division, which is in this country. I'm going to be talking about US only, but this also generalizes to other countries as well. That we have two parties, Democrats and Republicans, and they do disagree on many policy issues. We know that for a fact, But beyond that, they also dislike and distrust each other. And so they do have hallmarks of affective polarization. And this affective polarization has been rising. This is from Pew polling that's asking Democrats what are their views towards the other party, towards Republicans, so Democratic attitudes towards Republicans. You can see over the decades from 1994 to 2014, a larger and larger share of Democrats are holding very unfavorable, very negative views of Republicans. And this is also true on the other side. If you ask Republicans, as Pew has been asking them, what are their views towards Democrats, a larger growing share of Republicans is reporting seeing the other Democrats as holding negative views of Democrats, and in fact also thinking that Democrats pose a threat to the nation's well-being. So this type of emotional division is actually very bad for democracy in general and bad for the cohesion, social cohesion, and it's bad for our society as a whole. It prevents us from agreeing on issues. So I was interested in trying to see if we can study this online. And certainly, people do, mostly we look at we'll analyze textual interactions through messages people post online and social media, although it would be great to expand it to other types of media content. But even online, when people join social media, they communicate a range of emotions. I'm illustrating this with emojis. We don't use emojis to understand them. We use more sophisticated models, but this is just to convey this. And what we are relying on is the fact that language carries cues to emotions. You can have sentiment, for example, with positive or negative. You can actually, right now, we'll show you how we're using large language models to understand a range of emotions from anger and fear to joy and disgust and others. But even beyond emotions, there's other aspects of human affect that language can recognize. For example, toxicity, hate speech, moral valence of language. We can also start labeling or recognizing these aspects of human affect through language. And I will give you a little overview of how people have gone about over the years, over the last 2 decades, to try to recognize it. But right now, like, better and better tools are coming online to do that automatically. So early work on recognizing emotions from text focused on using dictionary-based approaches. There's a whole variety listed on the left. Probably the one that's best known is Look, because it was developed by social psychologist Jamie Pennebaker out of UT Austin. There's also another popular tool is this WKB lexicon, which basically the way this dictionary-based approaches work is like there's a list of words, for example, 14,000 English words that have been annotated for their emotional valence, either positive or negative, and also their emotional arousal, which is like the strength of the emotion. Is it really activated emotion like anger, or low arousal emotion like soft emotion like sadness, for example? And you can do the same thing, and people do the same thing with hate speech. What are the words that are connotative of hatred towards a group, or what is the words that are highly toxic? For example, obscenities would be marked as toxic. And so this gives you like an example of words, but psychologists have used these to analyze language at scale from social media. This is one of my nice early examples from about more than 10 years ago that sociologists actually, they took social media data, specifically millions and millions of tweets, 500 billion tweets from millions of people worldwide, and charted how positive affect fluctuates over the course of the day. And not surprisingly, this is often in social science, you see something that confirms what you already know, but it's nice to quantitatively confirm it. Not surprisingly, positive affect here, each of these lines shows the fluctuation of positive affect on different day of the week. There's weekly variations in affect, there's daily variations in affect. People express more positive affect in tweets on the weekends, not surprising, and less on actually Tuesdays, the day with least positive affect. But maybe more importantly, this type of cycles of affect, positive affect, actually they don't depend on culture. They're the same. They depend more on diurnal cycles, on weekly cycles, but not on culture. All over the world, these fluctuations of positive affect are very much the same, which is a nice way to say that we are all humans, we are all the same. Our mood, how we feel, depends on, at the first cut, how much daylight we get, and whether we are, enjoying leisure time or have to work. So this is one of the early studies. Over the years, as our language analysis methods have improved, our power to recognize emotions in text has improved as well. So what we are using in our work, as of like two years ago, but things are changing very quickly, very dramatically. We are using actually transformer-based language models, because dictionary-based methods, they're very easy, they're easy to understand, but they're actually very fragile, and they have many shortcomings. They can't, because they only look for specific words, they don't account for the context of the word that words appear in, like sentences. And they're very known not to understand the nuance of the language, like, for example, sarcasm. There for decades, sarcasm was the holy grail of natural language understanding. How do you understand sarcasm automatically? Right now, we have tools that really are great at understanding and explaining sarcasm to us. Okay, so these tools actually, here I will give you a little brief view. Like, this kind of transformer models are deep neural network based tools that analyze positions of words and interactions of words. They're very large, have billions of parameters, but these types of language models help us learn representations of text based on sentences, on sequences of words. And the way they work for emotion recognition is like given some ground truth data, suppose we have a body, like a corpus of sentences or tweets or messages that have been annotated for the emotional content. We train these transformer-based models to recognize emotions in a new piece of text. And so this is kind of the showing the architecture. They're very complex models, but they work relatively well. We evaluated them even in the multilingual context where we can recognize emotions and natively in over 100 different languages. And they give us decent performance. They're not going to be on par with human understanding of emotions, but what we lack in the quality, like, this is even with this decent accuracy, we can run it on millions and millions of tweets, and with the hope that, with the caveat that the noisy or errors would average out and we get a signal. And I'll show you that we are getting a good signal out of these tools. But what's been happening lately is actually, which is also really, really interesting and will be the next wave, and we're starting to use it in our lab as well, that these large language models, generative language models like ChatGPT, Llama, Claude, several ones have been introduced. They're coming in line. They allow this for this so-called zero-shot emotion recognition. You don't need to provide training examples to train the model. You can just ask it, what emotion is expressed in, and you go like, my day is off to a great start. The coffee machine is not working. We recognize this as a, maybe sarcastic message. Of course, if a lexicon-based model, dictionary-based model took it as, it says great, start, coffee, it's expressing positive sentiment. But if you ask this to ChatGPT, and this is an actual response, it gives you something that's really, really insightful. It says, the emotion is likely to be sarcasm, indicating frustration or annoyance. The phrase off to a great start is used ironically because the coffee machine is not working, is actually an inconvenience. So this is a great example of the power of language models to recognize the nuances of human expression. Or this is much more similar to the kind of tweet we're likely to encounter online in our data, and we can ask it what emotion is expressed, and stop wasting your money. You can read it the rest for yourself, and it's actually very reasonable explanation. It says emotion expressed in this tweet is predominantly anger. The use of strong language, along with the emphasis on, you can recognize capitalized, for example, through capitalization, indicates a high level of frustration and indignation. So here we are getting evidence that it's anger, frustration, indignation. So we're more and more, we're actually using this type of technology to recognize these fine-grained nuances of human emotional expression. So really, like as I was telling you earlier, this is the most exciting time to be in this area. It is indeed very exciting time to be this area. So what can we do with these models? So I will show you some of the very recent work we did to measure these emotional aspects, dimensions of political polarization online, specifically affective polarization. And we have several at our disposal, several very large-scale, massive data set containing millions and tens of millions of tweets. This is in the old days. We collected this data before Twitter became X, before Musk took over Twitter. So Twitter was providing an academic API, which we used to collect the data. So we have millions of users participating in discussions on different topics. So the data sets we have is about 35 million tweets from 6 million users that are discussing about abortion in 2022 when Roe v. Wade was overturned. We have actually a very, very long data set. We took just a subset of this data, but we have pandemic-related tweets over like 3 years of the pandemic. But here we are going to look at the first 6 months of the pandemic, which has 5 million tweets from 2 million users. And we also, for generalizability, we're also going to apply results to tweets about French elections. They're mostly in French. It's a smaller data set. It was collected in 2017. So the way I'm going to approach, at least for the US based data set, the first two data sets, we have developed methods to classify Twitter users as liberals or conservatives, or like as Democrats and Republicans. So we can group people into their own respective circles, their groups. So we have a group of Democrats, for example, a group of Republicans. And then we're going to look at emotions they expressed in replies, in reply interactions. So when a Democrat is replying to another Democrat, we call it in-group replies, and similar for Republicans. And when a Democrat is replying to a Republican or vice versa here, this is the out-group replies. And then we're going to use the language tools, analysis tools I had described earlier. We're going to use these tools to measure the strength of the emotion. And we can cover, actually, we're looking at 11 emotions. You'll see only some of them are important. So hopefully everybody here is comfortable with looking at box plots to look at the distribution of some number, some quantity. What I'm showing here is actually 6 different quantities. Most of them are emotions, also reply length. So for example, anger. I'm looking at anger within replies, in-group replies versus out-group replies. And each box is showing the distribution of the anger scores, the strength of the anger expressed in the reply. And the way to read this box plot is showing the distribution of replies. So the point is the mean of the distribution of replies. So the mean anger is about 0.3 strength, but roughly you should think like 30% of the tweets have on average have anger. This is the median of the distribution. The bounds of the box are the 25th and 75th percentile, and this is the kind of the 90th percentile distribution. So it's a broad distribution, but most of it is concentrated in this area. This is for in-group replies, when Democrats are replying to Democrats and Republicans are replying to Republicans. Now, this is the distribution of anger in the out-group replies. So when they're replying across the political divisions, you can see that what the mean and the median actually of anger is higher, and this difference between the means is statistically significant to high significance level for asterisks. The chance that we'd observe this type of difference purely by chance is less than 10 to minus 4. So anger is higher in outgroup replies. Disgust is also higher in outgroup replies. Toxicity is also much higher in outgroup replies. Okay, so these are the negative emotions actually higher in outgroup replies than in-group replies. However, fear, or I should first say joy. Joy is actually, you can see the joy expressed in in-group replies is higher than joy expressed in outgroup replies, which makes sense. Positive emotions. It makes sense with affective polarization that in-group replies are warmer, more favorable, and out-group replies are more negative. But we were surprised by fear. And across all datasets we study, we see that fear is higher in in-group replies than out-group replies. Fear is a negative emotion, just like anger and disgust, but it has this different behavior. And I spoke to some social psychologists, and they said they were not surprised. But they explained it makes sense because we are more likely to express vulnerability, to in-group member, than we're likely to talk about something that we are afraid of to an in-group member with whom we feel safe. And also spoke to a folklorist and also said, it makes sense because, for example, folklorists study legends and myths, and those generally deal with the threat that the group faces and how to go about the threat or hazard, how to fight the threat or hazard. So again, this is going to be talking. So this is, higher fear in in-group replies is expected because this is when a group is talking about threats, something that their group is facing, and how to overcome those threats. So this was unexpected for me, but also interesting and relates to psychology, social psychology. Another interesting and also very consistent observation we are finding is about the length of the replies. When people are replying to an in-group member, they actually use more words, tend to use more words than when they're replying to an out-group member. And it's also was wondering why that is happening, but that's probably because people are communicating more information to in-group members. Maybe, as a way to, how do you combat a common threat? You convey information, whereas when they're talking to out-group members, then mostly, using their words to yell and not to convey information. Okay, but these results or like demonstrate effective polarization exists, and this is for Roe v. Wade data. We were able to confirm it also for COVID data the same way. But actually, I was curious whether, because I'm a social network scientist, study social networks, I was curious whether we could find signatures of this effective polarization also in social networks. So the type of social network we are going to look at on Twitter is the retweet network. So suppose you have this universe of Twitter users. Suppose this is me. I retweet some content from this other user. So we create a link between me and this person. I retweet another person, so create another link in the retweet network, and I can link up the entire network like through this. So we are going to look at who retweets whom. So with these retweet networks are basically attention networks. Who pays attention to whom? We would love to use follower links instead, but that information is really hard to get from Twitter. So as a proxy of the follower graph, we use the retweet graph to define our social network. And then I'm going to, now that I have defined the social network, I'm going to look, what is the emotion expressed in the replies to people within the network. So, and I will show you that when people reply to people who are closer to them in the network, they express more positive feelings. And when they're replying to somebody who is further away in a social network, they're going to express more negative feelings. And in this cut of the problem, we no longer look at classify users. We no longer have in-group versus out-group dichotomy. We no longer look at the Democrats versus Republicans. We simply take a social network like the retweet network and look at the reply interactions of people within the social network. Okay, and then I'm going to look at how the emotion expressed in the replies varies as a function of the distance between the people within the network, within the social network. And we can measure distance any number of ways, and both actually the results hold across all different ways. For example, you can use shortest path length. How many hops through the network do I have to get from one person to the next? Or actually, what I like to use is actually PageRank distance. This is what is the probability that a random walk starting at one node, what is the probability it will get to this other node? Or we can also use other measures like graph embedding distance. They're all results actually the same across these different measures. So hopefully that's clear. So just wanted to show you what these networks look like. And these networks are really hard to visualize because they have millions of nodes. So we can't use a standard network visualization packages. What we are doing instead is embedding these networks in this lower dimensional space and showing you the embedding of the network. This is the heat map of the embedding. So for example, this is the Roe v. Wade embedding of the Roe v. Wade retweet network. Each point is the user. And when users are closer together, it means they have retweeted each other more or retweeted similar people more. And where they're further apart means that they haven't retweeted somebody similar. And the fact that it's brighter means that there are more users here within this region and this region than in other. And here there's fewer users. So this is a heat map of the embeddings. And you can see in the Roe v. Wade network, there's this you see this hallmark of polarization, what people call echo chambers or something. You have one group that's linked and you have another group that's linked, but they're not really well connected. So abortion debate, we know, is really highly polarized, or there's this kind of division of the network. But this is the retweet network of the coronavirus pandemic discussions in the first 6 months, and it doesn't have that kind of overt polarization with two large echo chambers of Democrats and Republicans, for example. Instead, has these little hotspots of different communities. Maybe they are more regionally based communities. I think this multifocal type of retweet network is fine. The French elections data set is interesting. We haven't looked into very much into it, but in 2017, there were 5 or 6 political candidates in the first round of elections. And then in the second round of elections, there were 2, Macron and Le Pen. And I think actually these large spots correspond to Macron and Le Pen. And then the other ones are like, the hot spots correspond to different political candidates. We haven't confirmed it, as my guess for now, but I think this is what's going on here. But mainly showing this to show you that we can visualize this is how the social retweet network is structured. There's a notion of distance here. For example, people who are Macron supporters, this is probably Macron, they're closer together than they are to Le Pen supporters. But even within this cluster, Macron supporters probably closer to Fillon. Well, actually, I don't remember my French politics, so I apologize. But they're closer to here than to these people. So there's a notion of network distance across this. Okay, so we have 3 data sets. We have distance. So now I'm going to show you how each emotion in interactions, in the reply interaction, varies as a function of network distance between the replying users. And I'll walk you through this plot. So the heat map in the gray here showing kind of how many reply interactions exist in this one. And you can see people reply across large distances. The people reply to nearby people, small distance, and people reply to faraway people, which is the large distance here. But if we're going to use regression to measure the strength of the emotion, anger, for example, as a function of network distance between people. And the regression, I'm showing here regression has a slope, and I'm showing the 95% or maybe 95% confidence interval. This is the relationship between anger and distance is well described by this linear relationship that has a slope. I'll show you the slopes later. So positive slope, meaning as people reply to somebody who is farther and further to them in a social network, in a retweet network, they express it more likely to express anger in their reply. They're more likely to express disgust as they're replying to somebody who's further and further away. They're more likely to have more toxic reply to somebody who's further away. But fear and joy actually have negative slope. So as people reply to somebody who is farther and farther, they express less fear and less joy, and also their replies are shorter. This is similar to what we saw in in-group versus out-group polarization. But now I'm not using the concept of groups. I'm just simply using the distance between people in a retweet network. And this is also very much the same across different data sets. So here I'm actually showing the slopes, so regression coefficients within each data set. Roe v. Wade. So, for example, people express, a positive slope for disgust, anger, and toxicity in abortion debates, network of abortion debates. There's negative slope for fear and joy, and also negative slope for the length of the reply. No emotion, like the likelihood that the tweet has no emotion, has a positive slope, which means people are they're more likely to express emotions to in-group members. Actually, in the Roe v. Wade, there's actually here in this other 2 data sets, people like no emotion has the probability, the likelihood that the tweet has no emotion is strongly negative, meaning tweets that are to in-group members are more likely to be non-emotional, which means the tweets to out-group to people who are further away have more emotions in them. And we see that in this, especially in the COVID debate, you see the disgust actually changes really quickly with network. This has a very large positive slope. Disgust and anger increase quickly with network distance, and so does toxicity. But fear and joy, just like in the Roe v. Wade dataset, fear and joy actually decrease with network distance, and so does the length of the replies. We can even look at the French dataset, for which we don't have liberal versus conservative, or we did not go through and classify users by partisanship. This is actually earlier iteration of their models that has slightly different division of emotions. So for example, anger, disgust were put together into the same cluster, and guilt and shame was also put together in the same cluster. But we see similar trends. So anger, disgust and anger are positive. High toxicity increases with as people reply to further and further. But soft negative emotions like fear and guilt, they decrease with network distance, as does joy. Yeah. So these results hold across languages, across topics of discussions. It's really like validates that this is pointing us to something that we are measuring that's real. So just to summarize this, negative emotions, they mostly like the strongly negative emotions, they increase with network distance. Anger, disgust, the use of toxic language to people who are far away from you in the network are more. So the replies to more distant users are more negative. But joy decreases with distance. So the replies to more distant users are less joyful. And fear also decreases with network distance. So and should also like to add that because we looked at 11 different emotions, including anger, disgust, fear, joy, but also happiness, optimism, love, optimism, pessimism, and sadness, trust, and surprise. So we had all these other emotions, but they don't show statistically significant variation with network distance or with in-group, out-group division. So we're just these ones though. So in summary, about affective polarization, this leads me to believe that emotions are embedded and help shape the structure of social network. People feel more warmly to those who are closer to them within a network. Our evidence for that is they express more positive emotions. And people feel colder towards those who are farther away from them in a network because they express more negative emotions, more toxicity toward them. And fear is mostly communicated with group to help bind the group and to address a common threat. And also people are willing to speak longer to their in-group members. So this is probably a good place to stop. I do have more content I'm happy to present, how we analyze the language, billions of tweets related to COVID discussions. But I'd like to actually stop maybe and hear your thoughts or questions on this topic. I see Santiago has a question.
Thank you so much for this very interesting presentation. Based on your research and what you have found, what would be